Hi, and welcome back. So this session is now a dive deep into a couple of features that we mentioned before. Just to be sure, is anybody new here that was not here in the previous session? So, okay, some movement in the session. So my name is Danilo, and I'm part of the Evangelist team, and I'm specifically focused on serverless. In the previous session, we saw what's happening in the serverless space and what were the most relevant reInvent announcement. Now we are diving into a couple of those that are also probably my favorite ones. We will see how Lambda layers work, how the runtime API works if you want to build your own custom runtime. It's not necessary to know the internal of the runtime API to use a new language. It's only important if you want to build a new runtime for your favorite language, but it's still interesting to know. And then we will do, probably half of the session will be a demo to use layers and runtimes to build something interesting. So layers. Layers is a way to centrally manage code and optionally also data that is shared across multiple functions. We found this to be complex for our customers because they needed to bundle everything, all the dependency with every function that they were creating. And this was also slow when they were creating an update, when they were updating a function. So this normally is custom code that is used by multiple functions. It can be standard libraries that you want to use to simplify your business logic. Let's say it's shared code that doesn't change frequently. Anything that is changing frequently, keep it inside the function code. But anything that is relatively standard is not maybe core to your business logic because you only use those as primitives. Put it into a layer. Layers, by default, are shared within the account, the AWS account they are created. But you can optionally share with multiple accounts within an AWS organization. So if you use AWS organization, you can easily share within all the accounts of your organization. Or you can share publicly if you want to create something for the public good. And the idea is that the function can reference reference layers also across accounts, as I said before. To build a layer, you just need to put those common components into a zip file and upload it as a Lambda layer. When you create a layer, you always create a new version of a layer. If you're familiar with versioning with Lambda functions, you know that you can update a function and you need to explicitly create a new version if you want. With layers, it's automatic. Actually, the primitives is create a new version. There is no create layer without creating a new version. And each version is immutable. So if you need to update, you need to create a new version of that layer. You can also delete a version. But if you delete a specific version, for example, I create version 1 of my shared libraries, then version 2 and version 3, I can delete version 1. But all the functions that are still referencing version 1 will continue to work. But it will be impossible to update or create a new function that use the deleted layer. So you can delete safely because you don't need to check if this layer is being used. We will keep the layer if functions are still using it. But when you want to update, you will not be able to use the deleted layer anymore. And if you look at layers, layers are identified using an Amazon resource name. And this is an example of the ARN. And at the end, you have the versioning number, version 1, version 2, and version 3. When you configure a function, can be a new function or update of a function, you can reference up to 5 layers. So there is a limit. This is a limit that we decided, but we may increase it. But the idea is that layers should not be too small. So it's not like if you use Node, any NPM module, you put it into a layer, and then you take 45 layers. This is not the idea we see layers. We see that you use a few. And in my personal view, but we're still seeing how customer will use layers, the idea is that you probably have a layer with all the dependencies of your function. You have maybe another layer with management stuff. So maybe your company is using some security or monitoring service that you need to plug into your Lambda function. And maybe another layer can be a custom runtime. So probably I'm expecting functions to use 2, 3 layers, no more than that. When the function is invoked, the layers are installed when we create the sandbox in the execution environment. And what we do is just we unzip all the layers under /opt. And the order of the unzip is the order of the layers. So when you configure layers, order is important. It's an ordered list of layers. And then in that order, we will unzip inside the /opt. So a layer can potentially overwrite the previous layer. This can also be good because maybe you install some framework and then you want to create a new layer that updates a few libraries or a few modules of that framework. And that works because the second layer will overwrite the previous one. The overall uncompressed size of the Lambda function with all the layers remains the same as before. It's 250 megabytes. So you can't use layers to have more space. So the space that you have for your Lambda function is exactly the same. You can use layers to organize how you distribute code, but don't expect to have larger functions because you use layers. And when you zip your dependencies, you need to have a directory structure inside your zip file so that when we unzip the file under /opt, the modules, the libraries will be seen by the different languages. So imagine that in front of those folders, there will be /opt because we unzip there. And this is the directory structure inside your zip file for the layer. So for Node.js, we expect Node.js /node modules and then / and all the node modules. So you need to create a Node.js directory, and then you can, for example, run npm here, and it will automatically work. Optionally, you can use a directory structure that includes the node version. For Python, again, you expect a Python directory, and then inside this Python directory, all the Python modules that you want to use. Optionally, we support the site package syntax that includes also the Python version. For Java, Java/lib is the class path. So put your jar into Java/lib, and it will be automatically seen by your Java Lambda functions. For Ruby, we support both gems and Ruby libraries. So Ruby is new to the Lambda platform. And for all runtimes, anything that is under bin, so it will be /opt/bin is in the path. So if you want to run an executable, you put it under bin, and you can just execute the executable without specifying the path within the Lambda function. And if you need shared objects, libraries, you can use lib, and it will go into /opt/lib. For example, if you want to use OpenCV, the Open Computing Vision library, within a Lambda function, there are a few shared objects because OpenCV is mainly written in C++, plus handlers in Python or Node.js. You put the shared objects under lib, and then you can put the Node.js or the Python handlers in those directories. Make sense? OK. To use layers, we also needed to update and add new APIs to the Lambda platform. So the create function and the update function configuration now accept this list of ordered layers, up to 5 layers. And then we have some APIs to manage the layers. So you can list the layers in your account. You can see the version of a layer. You can publish a new layer version. This is the API to create something new. There is, as I said before, you can publish a layer. You need to publish a layer version that you can also delete with the caveat that I said. So we will keep it for the functions that are still using it. Get layer version is quite powerful because it gives you all the metadata configuration of a layer. Because, for example, when you create a layer, you can say what are the compatible runtimes. Like this is a layer that works with Python 3.6 and 3.7. This is a layer that works with Node.js 8, and so on. If you run get layer version, you get all this metadata. And you also get a link to the zip file that you can use to download the layer. So if you want to inspect a layer that you're using or that maybe you created some time ago, the get layer version is the one that you need to use because you can download the layer locally. And then the last 3 are to check, add, or remove permissions to the layer so that you can add permission to other accounts, to your organization, or to everybody to use those layers. We also added support for the serverless application model. So there is a resource that is a layer version. Again, there is no concept of layer as itself because you always have to use a version. So for example, if you want to use a layer, if you want to create a layer in a SAM template, you can say this is the name, this is the description, this is the content of my layer, and you can provide a directory, and we will zip everything inside the directory to create the layer. Or you can provide an S3 link if you want, if the layer is already zipped on S3. The retention policy is different than normally. So normally with CloudFormation, if you update a resource, we delete the previous version and we only keep the new version. But by default, for layers version, the retention policy is retain. So we will retain, if you update a layer, we will keep the previous version and the new version and so on. You can optionally change this to be a different policy, but the default is retain. And when you have a layer that you create in the same template or that is already maybe being created, you can reference the layer in your function. So your serverless function has some code, the handler, and then you can optionally specify the list of up to 5 layers. This is an ordered list. And you can reference layers by ARN, or you can reference layers created in the same template by reference. And in the runtime, if you want to use a custom runtime, so we will see custom runtime shortly, the keyword that you must use in the CLI or in SAM or in the API is provided. So when you say that the runtime of a Lambda function is provided, it means that it's using the runtime API. And we will see what that means. We also integrated SAM support in the SAM CLI. So you can now use the SAM CLI to create layers in this way and to use layers in this way. And also, if you can use the SAM CLI to test your function locally and to debug locally. If you do that, we will automatically use the get layer version to download all the layers locally, and it is transparent for you. So you just say, I want to debug this function locally. It's using 3 layers. We download those layers and run everything locally within a container. We use Docker containers for that. Let's see how the runtime API works, and then let's see a demo of both. So the runtime API is a simple interface that you can use to bring any programming language that can run on Amazon Linux, or a specific version of a language that maybe we support, but not the version you need, for developing your functions. So in the console, you can select a custom runtime, or you can use provided in the API SDKs and CLI. And what happens is that the function must include, or the function or any of the layer of the function must include an executable file called bootstrap. And this is a fixed name. And we will use this executable as an interface between the Lambda environment and your code in any language you want. So this executable is responsible for the communication between your code and the Lambda platform. This executable must be in the root of the function or in the root of a layer. So if it's in the root of the function, it's the one that we use. If there is no bootstrap executable in the root of the function, we will look under /opt. Since layers, can overwrite each other, if you have multiple layers with a runtime, the last one will win, because it will overwrite the other ones. This file must be executable. So if you zip an executable file on Linux or a Mac, normally works. But if you use other platform, be careful, because the executable permission of the file must be put inside the zip file. Otherwise, if it doesn't have the executable permission, it will not work. And the Bootstrap acts as a bridge. And the Runtime API, they use a simple HTTP interface to communicate between the Lambda platform and your code. And Bootstrap, the main focus is to manage a response, so to receive the event, do the processing, and then give back a response or an error. You need also to manage the context, and of course, the execution of the function. The information on where is the HTTP endpoint and the environment is shared as environment variables with the Bootstrap environment. So basically, the Bootstrap executable can see an environment variable that is AWS Lambda Runtime API that has the syntax hostname port. And this will be the endpoint where the runtime API must be executed. There is also underscore handler that is the traditional function handler of a Lambda function. So it's script name, the syntax is script name without extension, dot function name within the script. So if you have a function with lots of files and functions inside, because you have multiple functions, the function that we execute with the Lambda platform is defined by the handler. This is standard with Lambda since 2014, and you specify the file name without extension, and then the function name within that file. Another environment variable that has always been there is the Lambda task root that tells you the directory where the function code is. At this point, the runtime API, the bootstrap, at the beginning will do some initialization. So the first time we create an environment, we recycle the environment for next execution, but the first time there is an invocation, we have to create the environment for the Lambda function. You do some initialization work. If you have an error during initialization, because maybe you can't find stuff that your runtime needs, you can post the error to /runtime/init/error. Then you start a loop to receive the events and process the events of the function. As you know, we never have multiple invocations in the same environment. So every environment is sequential. You get an invocation, you process the event, and then you wait for another invocation. You do get runtime invocation next. This is an HTTP call. You shouldn't be scared of timeouts, because we will freeze the function between invocations. So the function is freeze. When there is some content, we unfreeze and you get the event. So no possible timeout here. And in the response that you get, the payload of the get will be the event that you need to process with the Lambda function. And then in the headers, you get the invocation ID in this Lambda runtime AWS request ID header. And if you want to use X-ray with your runtime, we also get the X-ray tracing ID in this header. And you are in charge of propagating this as an environment variable to your function. So if you want to use X-ray with your custom environment. More information on this is in the documentation. At the end of the processing, so you can use any language that you want, you need to post to /runtime invocation and then use the invocation ID that you got from the get here in the path. And then you can post a response, or if everything is OK with your return code, or an error if there is an error. So it's very simple. The main loop is get and then post error or response. And the full endpoint that you need to implement is this. So this is an HTTPS, I think. And then you have the Lambda runtime API 2018-06-01. This is the versioning date for the runtime API. This is the current one. And then the final part here is the one that I was mentioning here. When we launched the runtime API, we released a few open source runtimes. We work as AWS, and also we work together with our partners. So as AWS, we launched the C++ runtime to create C++ functions, and Rust for creating Rust functions. And those are open source on GitHub. And you can there is a blog post on the compute blog and a blog post on the open source blog of AWS that describe how you can use those runtimes. And then our partners, they already started creating interesting stuff. So Alert Logic created a runtime for Erlang and Elixir. Blue Age, a runtime for COBOL. So you can now run COBOL inside Lambda. Node Source created a distribution for their Node Solid, robust distribution of Node.js. And Stakery probably work on one of the most requested languages now that Ruby is available, that is PHP. So you can also run PHP. So all the things that I was mentioning before, how the runtime API works, is important only if you want to create your own runtime. If you want to use a runtime, probably the runtime is distributed as a layer, and you can just take the layer and just use it transparently to you. The main difference as a user is that the runtime that are fully managed by AWS are also updated by us transparently. So if there is a security update for Node.js or Python, we apply that transparently, and you don't need to do anything. If you use a runtime through a layer, probably there will be a new version of the layer, and you need to reconfigure the function to use the new version of the layer. Otherwise, nobody will do that, and you will continue to use the old version. There are also a curated list of interesting public layers here on GitHub. So if you want to see what's possible to create with layers and not just runtimes, layers in general, this is an interesting place to go. Those are public layers, so as AWS, we can't enforce security on that. So if you use a public layer that is shared by someone, you might download the zip file, analyze the zip file, because it's your responsibility to use something that someone else prepared for you. So let's see how this works with a demo. The idea of the demo is first to work with layers. And let's see how we can use layers with Node.js. So I want to create a function that is using a few very common Node.js modules. So moment, request, and request promise. And then we will see with Python. With Python, we also created an AWS managed layer. So there is the idea for AWS to provide fully managed layers. The first one and the only one up to now is this one for Python that is providing you NumPy and SciPy so that you can use them easily. Those are mathematical libraries for Python that are normally quite complex to use with Lambda because they also have binary dependencies. They use low-level C++ mathematical libraries such as BLAST, if I'm not wrong. So normally you need to bundle these shared objects, and the libraries is not easy. So we wanted to simplify this experience, and we have this fully managed layer. And we're looking forward to see those layers available for Python 3.6 and 3.7. And then we will see how to add another custom layer for matplotlibing, for example. So let's start with Node.js. Oops. So let's go here on the console. So this is the Lambda console. I'm in Ireland. Perfect. As you can see here, we have the layers, as I mentioned before, and currently I have no layers. And let's create a function. Let's call it node demo. I'm using Node.js 8. Let's create a new role, and let's call the role like the function so that I can find it easily. And I don't need any other permission. And while the function is being created, let's go here. And here I have my node demo. So this is a very simple Lambda function that is using the moment and request promise. So moment is a date-time library that is very common to use with JavaScript and Node. And request promise is providing a promise interface so that in JavaScript you can use things like async and await with the request module. And request is a very common module for doing HTTP request from Node.js. From a security perspective, I normally say don't use external modules if you really don't need it. So Node.js has very good HTTPS and HTTP modules. So I normally try to avoid this. But for the sake of the example, I'm using request. And you will see the implication of that. So I just print the date and then download a website and write the logs. But let's create this function. So let's copy everything here. Here I have my code. I paste it. And then I save the function. Now I can zoom on the editor and test the function. I'm not using the event in this function. I'm just printing the date and downloading a file. So I don't need here, so I create an empty test event. With Lambda in the console, you can create test events so that you can test easily. So this is an empty test event. Now I say click test, and as you can imagine, I get that I cannot find the module moment. So normally I would need to install and bundle everything, but since maybe I have hundreds of functions that use the same module, let's create a layer. So this is the command line. I can create a node layer directory. Here I need to create a Node.js directory. You remember the directory structure that I showed before. And here I can run npm, so I want to install moment, request, and the request promise. Npm install, of course. And as usual with NPM, now half of the internet has been downloaded. And you can see the number of modules that are downloaded. So that's why I say for security reasons, be careful with the modules you use. Actually, Moment is quite good because Moment is just downloading Moment here. Request is downloading also other modules. So be careful when you do that. I have also the package lock created here with versioning. So I don't need that in the layer, so I move it out. I move it out a couple of directory. And now here, this is the point where I want. So I'm in the Node.js directory. Let's just. I have the Node.js directory here, so I can zip maximum compression, recursive directory, and then I want to call it node layer, and everything that is here. OK. So now I have the zip file, and I have also the package lock that I saved. So let's go back here in the console. I go in layers. So can you see? Let me see if I can. Because if I zoom too much, normally the console doesn't like it. Can you see from the last row? OK. I create a layer here. Let's call it node layer. And this is the description. So it's a very good practice to put the versioning of what you're putting in the layer in the description, because otherwise it's very difficult to understand what's there. So that's why I kept the package lock. So you can also maybe automate stuff. But let's see, for example, Moment. So for Moment, I'm using version 2.2.2. So here in the description, I say there is Moment 2.22.2, and then request some version, and then request promise and some other version. So use a syntax like this so that you know what's inside a layer. Now I can upload a zip file. You can also use upload a zip file from S3. And if your layer is bigger than 10 megabytes, it's much better to do that. But for now, it's not that big. So let's go here, demo, Lambda. This is node layer that I just created. Here you can declare what are the compatible runtimes. I think this works with Node.js 8 and Node.js 6. So let's declare this as the compatible runtimes. And now I'm creating the layer. So the layer is being uploaded, and this will probably be the first version. In fact, it's version 1. And it's available. And here you also get the ARN of the layer. So you see, if you have multiple versions here, you get the list with the version of what's inside. Is much easy to read. So the description is really useful for understanding what's inside that layer. So now let's go back to the function. This is my node demo. And as you see, now we have layers here where you can configure the layers of the function. If you use the CLI, you have the layer option that is similar, and then you have to use the LAN. So I can add a layer here. You can select from the compatible layers, or you can provide a layer by ARN if you prefer. Here I can list the compatible ones, and I have my layers and node layer because it's compatible with node 8. I can choose the version. Only version 1 is available. I just add it. And now I have here the reference layers. And if you have more than one layer, here you can also define the order, merge earlier or merge later. So the order, the layer will be unzipped in the /opt. So you have to save. And now that I save the function, as I can test it again. So let's go back to function. Let's take the editor again, and let's test again. And yeah, wonder of the wonder, here in the log, now I get the time that I printed using Moment, and the request library downloaded 187 kilobytes from the internet. So nothing fancy, but it's just an example of how you can create layers and use layers. So let's do something a little bit more interesting in Python now. So let's go back here to functions. And let's create another function that is Python demo. This is using, I think I'm using Python 3.6 here, so I'm not using 3.7 because I already have another library that I created for 3.6. Create a new role, and I call the role like the function, so I will find it back, and then I can just create the function. So for this function, I want to use the NumPy, SciPy layer. So let me look here. So this function is using NumPy to generate a random matrix. NumPy is very effective with linear algebra, and it's used a lot with neural networks that normally use lots of linear algebra inside. So I generate a random library, a second random library, and then I do the matrix multiplication. That is something that is annoying to build yourself. NumPy is also very efficient in memory and speed, for memory and speed. So it's, if you need to do this kind of things, don't build your own libraries. And then I'm using SciPy. So SciPy is built on top of NumPy and provides very high-level, powerful scientific functions. In this case, I generate 10 random points on a plane. And then I use, from SciPy, convex hull. Convex hull is a function that will find the minimum convex set that includes all the random points, something that if you need to build yourself is not easy. Lots of possible use case. Maybe you receive events from devices and you have the location and you want to understand what is the area affected by something, so you want to find the convex set of those points. And then it's printing those convex points. So I copy again this, go back in the console. This is my Python demo. It's Python. I copy and paste this, and then I save. As you see, also for Python, there is no impact on the code. So when we design layers, we wanted the code to just import or require in Node.js or in Java. So we don't want to have any impact on the source code. Layers should be transparent to use in the source code. Let's add the NumPy layer, otherwise I get an error here. So now I add a layer again. If I look at the list of compatible layers, now we also have AWS layers, and for now there is only one that is managed here, but we're looking forward to suggestions and to what kind of layers we can provide and manage for you. I choose this one. The last version is version 2, and I add it. Now I can save. And if anybody tried to bundle NumPy with Lambda knows that this was very annoying, because you need to find like 3-4 shared objects that depend on Amazon Linux. Sometimes you need to install it or compile them. It's not just a Python module. It's using C++ low-level objects. So now that the layer is saved, I can test the function. So I take the editor, test. Again, I'm not using the event here. I'm just generating function and the matrix and doing the multiplication. So I can create an empty event and use this empty event. And as you see, now I have my first, let me zoom a little bit, my first matrix, random matrix, a second random matrix, then the dot product of the two matrices. And then I use SciPy, so I generate 10 random points on a plane between 0 and 1. So 0.0 to 0.9, and then the smallest convex set containing all 10 points has, in this case, 6 sides, and those are the points. So you need to connect 0.9, sorry, we don't see all the 6. 0.9 with 0.3, 0.3 with 0.1, 0.1 with 0.4, 0.4 with 0.2, and 0.2 with 0.7, and then back to 9. So this works, but it's not really easy to understand. It would be great if I can plot this on a graph. And actually, there is a library that is often used with NumPy that is called matplotlib, but it's not included in my layer. So how can I do that? I need to create another layer so that I can use matplotlib easily. Matplotlib is also using libJPEG and libPNG for graphics. So you need to bundle low-level shared objects for the library to work. So to do that, what I did, I went and say, OK, let's search how the Lambda environment is built. And we have this description of the Lambda environment. And here we also give you the Amazon machine image, the image that you can use on EC2 to create an instance that has the same environment as the Lambda functions. So if I click here, I can start an instance that will be similar to my Lambda function. I actually already did that. I did that in North Virginia because I did that when the service was still in preview. And here I have an instance that I started that that I call making layers. So let's copy this. So let's do SSH. I think I have the SSH key here, EC2 user, and the domain. OK. And here I created a few layers for Python. And if I go in matplotlib layer, we see there is already the zip file, and there's also the Python directory. And those are the directories. So what I did, and this just a suggestion, is I started the instance, and I expect this to be similar to the Lambda environment. This is the site package of Python, but for any language, you look at the installed libraries. Then I installed matplotlib with all the dependencies. Then I checked back, and I took all the new directories that were created, and I copied all the new directories here, and then I zipped them. In this way, you know what is the difference and what you need to zip. Over time, expect this to be better, because as I said before, you can build layers with the SAM CLI, and the SAM CLI can use Docker containers, so it can emulate this environment. For now, it doesn't work, but the idea is that the SAM CLI could be used to build and install layers that are compatible without having to start an EC2 instance. But this is not so bad as an experience already. So this zip file I copied locally, and I have it here. It's in this directory. So if I check, and you see I have the path Python / and then in this case I use the site package directory, but you can also remove this part of the path. It works the same. In this case, maybe it was useful because this is really dependent on the Python version. So I know that this was built for Python 3.6. So what I can do, if I go back on, let's close EC2 and this. Let's go here on layers, and let's create a new layer. This is a matplotlib layer. Matplotlib, I don't remember the version, but always put the version here. It's a good practice. So this is slightly larger than 10 megabytes. So normally you should go through Amazon S3. If it's too big, you can get timeout from the console. But in this case, I want to risk something. It's a live demo. It can't go everything OK. We need to try. And then the compatible runtime, this was built for Python 3.6. Create. The compatible runtime is just for your searchability. And you can always force by ARN to import a module if you want. So now we're uploading and configuring. So we have the new version of the layer. So now I have 2 layers here. Now I go back to my Python demo. And if you look at my code here, so first thing, let's add the layer. So I go on layers. I do that because otherwise I forget. And now here, if I look for compatible layers, I see that I have both the AWS layer that I was already added and then my layer. And there is version 1. Now I have 2 layers, so I can also play with the order. So probably it makes sense to install before NumPy and SciPy and then matplotlib. But here you can go merge, select and move them up or down. So now let's go on the code. Let's save, because you need to save the configuration change. And then this save is taking a little bit more time. And if you see the source code, there was some code that was commented out that was needed for my edit. And if you see here, also I'm using an S3 bucket to upload the image that I create with the plot. So to write on S3, I need some permission. So while this is also saving, probably it's saved, but let's go quickly on IIM, and let's add permission to write in this bucket. So let me copy the bucket. So the bucket that I'm using, for some strange reason, is in Oregon, because I did that for the Las Vegas demo, but it still works. Let's go here on roles. Let's search for Python demo, and this is the role that has been created for my function. And now I can add an inline policy. For example, my service is S3. I need to be able to write and do a put object. And the resource is, I can specify a resource by arm. So this is the bucket name and any file in the bucket. And now I can review the policy. This is S3 write, just a name for the policy. And now the policy can, the Lambda function can put object on this bucket. Let's go on the bucket. Probably there's something that I left there. Yeah, there is this convex, and then there is an image. Let's delete this image that was already here from another demo. So now it's empty. Now back to the function. So let's uncomment some stuff. So I import the mathlib function. I use the S3 buckets, and this is the object. And here at the end, there is this final part that is using PLT plot is the name that usually used with matplotlib. I plot the original points. Then I plot the points taken from the convex hull. Then I have an image. And when you have an image and you need to upload an image to S3, the easy way is to write the image on a file. But I usually try to avoid using the /tmp of Lambda if not necessary. Also because /tmp is always 512 megabytes. Memory can reach 3 gigabytes, so you have more memory than disk. So in this case, with Python, I can use bytes IO, but any language has a way to manage images in memory. With bytes IO, I create a construct that is similar to a file in memory, where I store my image data. And then from Boto, the AWS SDK for Python, I upload this from memory straight to S3. My suggestion is don't use /tmp if you don't need it, because probably you have more memory than file system. But it depends. If you want to run this with very little memory, maybe it's not a good use case. The final, so if you see, matplotlib is a library that normally is used as a global object. So you see the plot that is here is the same that I'm using inside the function. So it's very important that you clean the object at the end. If you don't clean, and you have multiple function execution that will go on the same environment, they will continue to plot on top of the same graphics. So when you have global variables, so try to avoid anything that is global. If you have variables, declare the variables inside the function. But if you have anything global, think that you need to clean it at the end of an invocation for the next invocation. And that's what the clause is doing. So let's save now and test. So the function now should run similarly to before, but since I want maybe to make it a little bit more interesting, let's put not 10 points, but 100 points to generate randomly. And let's increase the timeout to 30 seconds just to be sure that we have time to process 100 points. Probably yes, but it's better not be. I have 128 megabytes, so it's not very fast, this function. OK, so let's go here and test. So now the function is doing the matrix multiplication as before, then it's generating 100 random number, and then the convex set, so rounding my number. So this is the matrix as before, then the 100 numbers. And now the convex set has 11 sides, and those are the points that you need to connect to create the boundary. But now I also uploaded this on S3. So if I go on the S3 bucket and I refresh, I see that there is an image. I can open the image and then unblock the pop-up request. And this is the image of what we just built. So those are the 100 random points, and this is the convex set surrounding all of those. So apart from the mathematical implication that maybe are not of interest of everybody, this is a way to quickly add new capabilities to a Lambda function. And when you create a layer, then you can just use the layer with any function. So it's something that can be shared within a company. It's something very well structured. So let's now try something different. So let's go back here. And the second part, I want to create a custom runtime. And what is the language that you always wanted to use to create a globally scalable API? Bash, of course. So let's create an engine for Bash functions for the Lambda. It's probably the hello world of the runtimes, but it's also easy to understand, so I like this example. So I need a bootstrap that will be used for this runtime, and and a file containing the function that I want to run, hello.sh, for example, for my Bash functions. So let's go here, and let's look at the layer first. So this is the bootstrap layer. Let me just close this so that we have a little bit more space. So this is an executable. So it can be a binary executable. In this case, it's a script. It's a shell script. The first command, I'm not entering into all the details of Bash, but basically it's saying that in case of error, this script should fail and report the right error code. So it should not continue like normally Bash script would do. And this is a best practice that we require runtimes to do. So a runtime is expected, in case of an unmanaged error, to fail and report the error to the Lambda environment. And we will recreate another environment. Set X is just for debugging. It will debug stuff. Everything that I echo, that I print, will automatically go to CloudWatch logs. So you can print for debugging. This line here is quite interesting. Again, the detail of the Bash script are not important, but in this case, I use source to import the function that I want to run. I know that the Lambda the function code is under the task root, and here I have the underscore handler environmental variable that, as you remember, has the syntax script name without extension dot function name. So here I cut the handler at the dot, and I take the first part. So this is the file name, and then I add the extension .sh. And source will import this function in the memory of this script. And then it starts the loop. It starts, try to zoom a little bit better, but I'm doing worse. OK. I start the loop. And the loop will, I have to store the headers. And for Bash, I create a temporary file to do that. This is how it works easily. Then I have to get the event for the first invocation. So the event, I use curl to do an HTTP request. I store the headers there. And then I call the Lambda runtime API endpoint with the runtime invocation next. So as I said before, you runtime invocation next. So this script will be freezed. When there is an invocation, this will succeed and get the event and write the headers here. Then from the headers, I do some magic with some cat and Unix stuff to extract the invocation ID from the headers, and I store it here. And I log it. And now I have to do the response. So for the response, I have to execute the function that I imported here. So I take the handler, I cut with the dot, and then I take the second part. It's the function name. I execute this function, passing in input the event data. And the result is the response. And now I have to post the result. So I post the result at invocation, the invocation ID, and response. And I get the response back. So this is probably the shortest bootstrap. There's a little bit of Bash syntax that maybe is not of interest of everybody, but important to understand the overall flow. It's just a get, process, and post. And then from the handler, you get the file and the function name that you need to use. Now let's look at the function that is very easy. This is the function. The file is called hello.sh, and inside hello.sh there is a function that I call handler. And this function is taking the event data, but it's actually just logging the event data. And then it's just sending a static response that is built for the API gateway. So it's just saying status code HTTP 200, content type I think is just saying that is UTF-8 because I'm using some non-standard Unicode characters, and then say hello world in a couple of languages. And then I print it for debugging. So this is an example of a Lambda function written in Bash. Now let's create this. So the first thing that you have to do is create a layer. I already zipped everything, so create layer. This is my Bash runtime. This is for Bash. I'm not specifying a version because I'm actually using the one in the Lambda environment. And then I can upload the runtime that I already zipped before. Lambda Bash layer. Now there are no compatible runtimes. This is a custom runtime, so I can't declare a compatible runtimes here. We're actually going to change this because a side effect of this is that since there's no way to declare this as itself a runtime, it means that it's not discoverable in the console, and I will need to copy and paste the ARN. But we added at API level the possibility to declare a runtime compatible with provided. That is the keyword for a runtime. So I expect this to be a little bit better in the future. It's something we're still thinking of. So for now, I have no compatible runtimes. I create this layer, and then I will need to save the ARN here. So I copy this ARN that includes the layer version. Now I want to create the function. So I create a new function. This is a Bash function. Now I have to specify custom runtime here. And since this is a custom runtime, there will be no editor because we don't know which is the language. So we can put an editor for something that we don't know. I will need to upload a zip file. And I create a new role with the same name as before. Let's do this so that I don't need. So this is a new function. Lambda knows that it's a custom runtime, so it can't show me an editor. But I already zipped the function here. And it's taking a little bit more than usual. It's getting tired at the end of the hour. OK. Now here, you see I don't have an editor, but I can upload a zip file from S3 or directly. So I upload my function here. Bash functions, save. And yeah, let's save. And now I have to add the Bash layer. And by the way, when you use custom runtimes, you can also bundle the bootstrap together with the function. It's not mandatory to use layer. But using layer is much more flexible because you create the layer once, and then you can use it with multiple functions. So depending on what you want to do, you might not need to do that. But now I go in layers. I add a layer. Now I have no compatible layers, so I need to provide the layer by ARN. As I said before, this is what we want to simplify, and save. So now the function has a layer, and the code has been uploaded. So let's try to test it. Again, I'm not using the event a lot, so I can just give an empty event and create the test event, and then test. And as expected, I got this, so the hello world for the API gateway. And if we look here, we get the log of all this plus that you see is because I did the set X with the Bash script. So this Bash script is doing the debug of everything that is doing. So I have the full debug of everything here, and I have the usual times. If I test this again, we can see the execution time is it's still not the fastest, 200 milliseconds. So Bash is probably not really internet scale. But now we can do something more interesting. We can add, for example, an API gateway here and say that I want to create a new API, an open API, and save. And now I have the endpoint that I can run, and now I'm running a globally distributed. I closed everything. Sorry. I'm running a globally distributed API running on the Lambda platform using Bash scripts. It's just reloading. Bash function, API gateway, runtime. Okay, and I can reload, and still not probably the fastest. So now that you can create Bash functions and Bash API, I think your developer life is different. Actually, you can look at the custom runtime. So if you're interested in PHP or Erlang and Elixir, that I think would be a good fit for an event-driven architecture. I'm still waiting for the first one that will create the Perl runtime, because I used to play a lot with Perl, I think 20 years ago, but still a good language. Thank you. We have a few minutes, and after this, I think we have a break, and then there is for lunch. Break for lunch, and then we'll start back with another session when we will dive deep on the AWS CLI for SAM and the serverless application model. Happy to take a few questions if you want. Otherwise, I'm here, and you can just ask me.